Hello, so in this video I'll be explaining, as you see here, how to take implicit differentiations and the process behind it. So basically I just wanted to start off by clarifying or saying exactly what an implicit expression is and how it differs from a explicit expression or equation. All right, so as you can see, I've already wrote an example of an implicit expression. So an implicit expression is basically an expression or equation where you have x and y mixed up on both sides of an equation. So in this case, you see that you have x squared plus yx equals yx. On both sides of this equation, you have x and y mixed up together. So this is an example of an implicit equation. Another example of an implicit equation will be, let's say you have y plus x equals xy. Again, in this case, you see that x and y are mixed up on both sides of the equation. So this is another example of an implicit equation. All right. And how does this differ from an explicit expression or equation? So an explicit expression or equation is where you have y and x not mixed up. Rather than being mixed up, they're not mixed up on both sides of an equation. So for example, let's say you have y equals x plus 3. As you can see, let's draw lines to show the difference. As you can see here, y is by itself on one side of the equation, x is by itself on one side of the equation. So this is not an implicit expression. So when you're taking implicit differentiations of expressions or equations, you have to make sure firstly that it is an explicit equation. So the process behind taking implicit differentiation. So first you just you basically start off by taking the derivative of the expression. When you take the derivative of, this is the special rule in this. When you take the derivative of a term that includes a y, you just tag on a dy dx to the derivative of the term that you, or tag a dy dx onto the term that you took the derivative of. And then the last part is just solving for dy dx. So let's just go into an example because, verbal explanation is not enough. So let's go ahead and start. So let's say you want to take the implicit differentiation of this equation. So let's say you have x squared plus xy plus sine y equals 3y. Hey, look, my handwriting is getting better and better. Or less sloppier. So again, the first part, the first step, you take the derivative of the equation. So the derivative of x squared is, as we know, 2x. The derivative of xy. So yeah, as you can see here, x and y being multiplied, so we would have to use the product rule, and the product rule basically states you take the derivative of the first part, leave the second part, plus you take the derivative of the second part, leave the first part, leave the first part. So derivative of x is 1, leave the second part, y, plus the derivative of the second part is 1, or the derivative of y is 1, times the first part. All right? I'll fix that later, or simplify that expression later. So let's take the derivative of sine y. So the derivative of sine y is cosine y. Oh, see here? See, I forgot something. I'll get back to it. Cosine y dy dx. And the derivative of 3y is 3 dy dx. Alright, see? Right here. This is very crucial. Right here when I took the derivative of y, in this part, the derivative of y I said was 1. And as I stated earlier, when you're taking the derivative of a term that includes y, you tag on a dy dx to the term. So here, what I should have done, let's write this whole expression over. So we got 2x here plus 1 times y is y, plus the derivative of y is actually 1 dy dx. So that will be dy dx. Dx times x, right, plus cosine y dy dx equals 3 dy dx. So that is the actual derivative of this expression or equation right here. But we're not done. We took the derivative. The second step, or the last step, is to solve for dy dx. So doing this, what we'll start off by doing is just moving each expression that includes, or term that includes dy dx over to one side and leave any term that doesn't include dy dx on the opposite side. So here we can just let's just subtract 3 dy dx, or just move it over to this side of the equation. Dy dx. Oh, I wrote that so wrong. Sorry. Dy dx minus 3 dy dx. Alright, so we moved everything that includes dy dx to one side. So this will cancel out. You'll be left with, let's just write this over real quick because I'm running out of space. You'll be left with, can we see? You'll be left with 2x plus y plus x dy dx plus cosine y dy dx minus 3 dy dx equals 0. So we moved everything that includes the dy dx to one side. Now we have to move every term that doesn't include dy dx over to the opposite side. In this case, that will be the 2x and the y. Hopefully you guys can understand my handwriting. So let's write a little bigger. Dx dy dx plus cosine y, dy dx minus 3 dy dx equals, we're moving this over to, moving 2x and y over to the other side of the equation, or of the equation. So you'll get minus 2x minus y. So now, again, what we are trying to do is solve for dy dx. As you can see here, all the terms on this part of the equation include a dy dx, so we can just simply factor out the dy dx, and we'll be left with dy dx, again, we're factoring out the dy dx. When you factor out the dy dx from x, you get x. Plus, when you factor out the dy dx from cosine y, you get cosine y. When you factor out the dy dx from minus 3, you get 3. Equals again to x minus y. So this was the part where I would usually get confused with, but it's fairly simple. We have the dy dx factored out. We're trying to get dy dx by itself, or we're trying to solve for dy dx, and it's being multiplied by x plus cosine y minus 3. So all we simply have to do now is just divide, or put it over this whole expression. So that'll be over x plus cosine y minus 3. And we'll do the same thing on this side. X plus cosine y minus 3. So our answer will be, after these cancel out, we'll have dy dx by itself. Our final answer with the implicit differentiation of the equation we took would be dy dx equals minus 2x minus y over x plus cosine y minus 3. And this will be our final answer. So the implicit differentiation of x squared plus xy plus sine y equals 3y would be dy dx equals minus 2x minus y over x plus cosine y minus 3.